mathematicians, today we're going to learn a new algorithm for multiplication. We've already talked a lot about our traditional algorithm in class, where we stack our numbers and we do some multiplication and addition, flipping back and forth between the two. And I've noticed when we've been working with our standard algorithm that we've been having a little bit of trouble with where our place values go and why they go there. So I think this new multiplication algorithm will help us keep our place values straight. This algorithm is called the lattice algorithm. And the first problem we are going to solve with our lattice algorithm is 43 times 53. Now, the first thing we have to do to solve our lattice problem is set up our lattice. We have to have two columns because it's a two-digit number across the top. 4 and 3. Our second factor tells us how many rows we need on the vertical line. So we have 53 is two digits, so we have a 5 and a 3, and that gives us 2 rows. And now we need to put our diagonals in. Our diagonals help us keep track of our place values. So each square gets a diagonal. In each small square, our tens is going to go on top of the diagonal, and our ones is going to go on the bottom. So I'm going to start by multiplying our 4 and our 5. 4 times 5 is 20, so our tens goes on top, and our ones goes on bottom of the diagonal. Now I'm going to move to 3 times 5, which equals 15. Our tens go on top, 1, and our ones go on the bottom, 5. And now I have my 4, and I'm going to move on to multiplying it by my 3. 4 times 3 is 12. My 1 goes on top, and my 2 goes on the bottom. And now I have 3 times 3, which is only a ones place. So in our tens place, we put a 0. And then our 9 goes below the diagonal. Now I'm going to extend our diagonals outside of our square. These diagonals across the whole square represent our different place values. So this is the ones place. This is the tens place. Our hundreds place. And our thousands place. Alright, so now we're going to add our diagonals along the diagonal line. So our ones place only has one number, and that is 9. So in our ones place, we put a 9. In our tens place, we have 3 numbers, and we have to add them all together. We have 5 plus 0, which is 5, plus 2, which is 7. So we put a 7 in our tens place. Then in our hundreds place, we have 1 plus 0, which is 1, and plus another 0, which is 2. So our 2 goes in our hundreds place. In our thousands place, we again only have one number. So that is our thousands. So we put a 2 in our thousands place. This is our answer. So 43 times 53 equals 2,279. With this form of multiplication, it keeps our place values very nice and neat, and we know what each of them means. But why does it work? We know that 43 is really 4 tens and 3 ones. So when we multiply 4 by 5, which 53 is really 5 tenths and 3 ones, we're really multiplying it by 50. So we have our 4 tenths, which is 40, times our 5 tenths, which is 50. So 40 times 50, which equals 2,000. Because that equals 2,000, our 2 goes in our thousands place, which you can see here. When we multiply 3 times 5, the 3 is in the ones place, so it's just 3. The 5 is in the tens place, so it's really 5 tenths to make up our 53, so that's 50. So 3 times 50, we can do this really easily by 3 times 5 equals 15, put a 0 at the end, equals 150. When we do 4 times 3, our 4 is in our tens place, which is 40, times 3 is in our ones place, so that's just a 3, which equals 4 times 3 equals 12, add a 0 at the end, 120. When we do 3 times 3, they're both in the ones place, so it is just 3 times 3, which equals, in our heads really quick, 9. So this is why it works, because our 2,000 goes in our thousands place with the 2. Our 3 times 5, 150, our 1 went in the hundreds place, and our 5 went in the tens. When we did 40 times 30, we got 12. 40 times 30, we got 120. Our 1 went in the hundreds place, our 2 went in the tens. And when we did 3 times 3, we got 9, which had 0 tens and 9 ones. And when we added them all together, this was our answer. Now, I have another problem that we're going to do, and it's going to have some carrying, because we do our carrying with our standard algorithm, and you can also do carrying with your lattice algorithm. So next I'm going to do a problem that has that. Our next problem is going to be 27 times 48. And again, our first step is to set up our lattice. Our first factor has 2 digits, so we have 2 columns across the top, 27. And then on our vertical line, we have another 2-digit number, and so we'll have 2 rows. Now we have to draw in our diagonals in each square. And we have our place values along the sides, our ones, tens, hundreds, and thousands. So first we have to do 2 times 4, which is 8. So our 0 goes above our diagonal line because we have 0 tens, and our 8 goes below because that's our ones. Then we have 7 times 4, which is 27, 28, which is 28, so our 2 goes in our 10 spot, and our 8 goes below. Then we have 2 times 8, which is 16, our 1 goes above, and our 6 goes below. And then we have our 7 times our 8, which is 56. Our 5 goes above, and our 6 goes below. Now we're going to add our place values up. We have 6 in the ones, and that's it. So we put our 6 in our ones place. We have 8 plus 5, which is 13, plus 6, which is 19. Our 9 stays in the tens place, and our 1 goes to the hundredths place. We carry our 1. Now we have 1 plus 2, which is 3, plus 8, which is 11, plus 1, which is 2. Our 2 stays in our hundredths place, and our 1 moves to our thousands place. Now we have 1 plus 0 in our thousands place, which is really just 1. So we put a ones in our thousands place. And our answer is 1,296. So when we carry, similar to how we carry in our standard algorithm, we just move our tens place up to the next place. So when we have we keep our ones in the tens place when we had our 19, and we moved our 1 up to the hundreds place. So we just carry to the next place value. So both algorithms work for multiplication, and it's really up to you what you choose is best, but I want you to try a few using the lattice algorithm to see how it works, and we can talk about it in class tomorrow. And I want to know your opinions on which works better for you. Have a nice night.